In this video, we're going to talk about systems of equations and specifically how to solve by graphing. So recall that a system of equations is two or more different equations. We're just going to look at two, and the solution can be a number of different options here. So typically, we're going to see one solution where the lines intersect here. We could have no solution if the lines happen to be parallel, or if the lines are the exact same. There's an infinite number of solutions. So when we graph, it's a lot easier to graph when our equations are written in slope-intercept form. So in this example here, we've got one equation that's slope-intercept, so we have to convert this other one here. All we have to do is subtract 3x, and now we've got two slope-intercept equations, and we can graph from there. So from here, we've got y-intercept of -4. I graph that here. It has a slope of 1/3, so I go up 1 over 3, up 1 over 3, down 1, left 3, and I draw in my line. Then I go ahead and graph my second equation. I've got a y-intercept of 6 up here, slope of -3, so I go down 3, right 1, down 3, right 1, and then continue until I find this intersection point, which gives me my solution of 3, -3. So what that's telling me is this is the only point on our graph that if I were to plug into both of the given equations in our system, it's going to be equal in both equations. If we take any other point on either line, it might work in, or it's going to work in one of the equations, but the other equation is not going to give us two values that equal each other. Okay. As far as lines that are parallel where we have no solution, if both equations are in slope-intercept form, then we can just look at the coefficient in front of x that tells us our slope. And if they're the exact same, we don't even have to graph. We know that there is no solution. Also, once we get into slope-intercept form, they're both going to be y equals. There's not going to be any other differences with it. So if it happens to be the same line, then once we convert both equations to slope-intercept, they would look the exact same. And then again, we would not have to graph. We just say that there are infinite solutions.